Hey everyone, and welcome to G Fun Facts Online. Whatever device you're listening on right now, your phone, your laptop, your smart speaker, it has one thing in common. At its heart is a tiny slice of an element that powered our entire digital world: silicon. But what if I told you the age of silicon is coming to an end, that the future of computing is flat? For decades, we've lived by Moore's law. The idea that the number of transistors on a computer chip doubles about every 2 years, making them faster and more powerful. We've done this by shrinking those transistors, which are basically tiny electrical switches, down to incredible sizes. But we're hitting a physical wall. When you try to make silicon transistors just a few atoms wide, they start to misbehave. They begin to leak electricity, like a faucet that won't turn off completely. This wastes power and generates a ton of heat, threatening to stop our technological progress in its tracks. But just as one era reaches its twilight, a new dawn is breaking, illuminated by a class of materials so unbelievably thin, they are considered two-dimensional. This is the dawn of 2D material computers. The journey into this flat new world began in 2004 with the discovery of graphene, a single layer of carbon atoms arranged in a honeycomb pattern. This Nobel Prize-winning discovery gave us a material that is incredibly strong, transparent, and a phenomenal conductor of electricity. But for building transistors, it was almost too good at conducting electricity, making it hard to switch off. This is where the rest of the 2D family comes in. Scientists have discovered a whole suite of 2D materials, with the most promising for computing being a group called transition metal dichalcogenides, or TMDs. Materials like molybdenum disulfide and tungsten diselenide are natural semiconductors. This is the crucial part. Unlike graphene, they have a natural off switch, which is the fundamental requirement for a transistor in a computer chip. So what's the big advantage of being atomically thin? Well, that extreme thinness allows for perfect control over the flow of current. It solves the leakage problem that plagues tiny silicon transistors. This means we can build switches that are not only smaller, but also far more energy efficient. In theory, 2D material transistors could operate at terahertz speeds, a massive leap from the gigahertz speeds of today's computers. Plus, their flexibility and transparency open the door to mind-bending technologies like rollable computers and transparent smart displays. For years, this was all theoretical. But in a massive breakthrough in June 2025, researchers at Penn State University announced they had built the world's first computer entirely from 2D materials, no silicon components at all. They ingeniously combined two different TMDs, molybdenum disulfide for one type of transistor, and tungsten diselenide for the other, to create a working computer circuit. It was a simple one-instruction circuit, but it was a monumental proof of concept. It proved that integrating these materials on a larger scale is a tangible reality. Now, before you rush out to buy a 2D laptop, we have to be realistic. The path to mass production is filled with challenges. The biggest hurdle is manufacturing. Creating perfect, wafer-sized sheets of material that are only a single atom thick, with zero defects, is an immense engineering challenge. But the potential is so great that researchers worldwide are racing to solve these problems. And the future these materials could unlock goes far beyond just faster phones. Their unique properties make them ideal for next-generation computing. We're talking about neuromorphic computing, building computers that mimic the structure of the human brain, allowing them to learn and adapt. In the world of quantum computing, 2D materials could be the key to creating stable and scalable quantum bits, or qubits, unleashing computational power to solve problems currently impossible for even our biggest supercomputers. The era of silicon has been extraordinary, but the dawn of 2D material computers promises a future that is thinner, faster, more energy efficient, and even flexible. The future of computing is flat, and it is incredibly bright. Thanks for listening to G Fun Facts Online. Be sure to subscribe for more fun facts about the world of tomorrow.